Alright everybody, so what we're going to do now is install my camshaft. So I'm putting a aftermarket camshaft in. There's nothing wrong with my original camshaft other than it makes this thing run weak. So in my hands is my stock camshaft. There's nothing wrong with this camshaft. I can reuse it, but given the specs between this stock camshaft from the information you can get from the same book, the Haynes manual, compared to the specifications of the 422 cam, which is the biggest production cam you can get for a 4-liter OHV. This is tiny. This camshaft's tiny. For what I'll be doing with the motor, we're going balls to the wall. We're going full blown. I'm going to break things. So I'll put some information from the Haynes manual about this camshaft. There's also, I believe, 4 different camshafts Ford made. 2 I think were slightly different for more torque and manual transmission applications, but realistically I don't care enough to mess with any sort of stock camshaft. I'm putting the comp cams, you can kind of see there, the 492-8 part number. There's a 410 one, 410-8 I believe it is. That's the slightly smaller camshaft. Again, I went with the biggest production one you can get. You can also go a custom camshaft route. I'm not doing that. I think it's about $100 more for that, and then you have to pay for shipping. Whereas this is free shipping from Summit, and it's a production camshaft. So you do have to change, per comp cams, you do have to change the valve springs, and you need custom push rods, which we'll be going over in a later video. But I'm going to install this camshaft right here. So I'm going to be doing that, and then on the block here, I'll give you a picture of this one, this cam bearing. You really can't see down in there, even with me, my eyes, I can barely see down in there. These cam bearings, given the picture you'll probably see, they're okay. They have some wear to them, but nothing alarming for me to actually care to change them. As I said before, I'm going to throw it in there, make sure it feels just fine, because all the bearings, the cam bearings, look okay enough to reuse. Besides, I don't have the tool to pull the cam bearings out and then install new cam bearings. The other thing you got to understand, the way this motor is made, this cam bearing is the biggest, and each journal for cam bearing that goes down the line gets smaller and smaller and smaller. So realistically, you have to change the cam bearings. This plug at the back you got to pull out, and then you knock the bearings out this way with a tool that's as long as the block, or if not longer, and then you have to knock the bearings back in with the same tool, but there is an orientation because the oiler hole is up here where my finger is on every one. On the timing set here, this is an oil hole, that's an oil hole for the tensioner, this is the lube, the chain, and then this is an oil galley hole, and this is an oil galley hole, and this is an oil galley hole. Both these oil galley holes are for the lifters. The thrush washer plate for the cam covers those holes. So it's only about that, and then you have the bolts that keep it in there. But I'm gonna grab the camshaft. I'm gonna lube it up with assembly lube and stick it in the block, and then we'll time it and we might go on from there depending on how long I want to make this video. Alright, when you get your camshaft, you'll get some information about the camshaft. Valve adjustments, it's hydraulic, so you just use stock lifters. Gross valve lift is 0.5. I believe my stock cam is like 0.275 or 272. It tells you duration, 270 degrees of engine rotation, and then 284 for the exhaust for degrees of engine. The timing. Alright, so when you look at this information, this will tell you what degree the intake valve opens at bottom dead center, and then the degree in which the it closes after bottom dead center. That's before top dead center, after bottom dead center, before bottom dead center, and after top dead center. This right here just basically, if you imagine a degree wheel on the front of the crankshaft, this will tell you when the intake valve opens and when the intake valve closes, and when the exhaust valve opens and when the exhaust valve closes. That's good and all when you're doing a camshaft profile check with the crankshaft to make sure the timing is correct, because you can get a profile of camshaft that is either retarded a few degrees or advanced a few degrees. But this cam, well, comp cams in generally are pretty good about being quality control is actually pretty good. On top of, one, I don't have the tooling to actually check the degree of the camshaft. Two, I'm not going to, because this engine does not have any aftermarket adjustable timing set that I know of at this moment in time, which means the timing set you get is set for one setting, and that's stock, which I actually don't know what that is. But you're unable to adjust the camshaft advancement or retardedness for this engine because there's so little aftermarket for it that, from my knowledge, there is no adjustable timing set. I just have a stock timing set, so I'm not going to bother checking the actual camshaft to crankshaft relationship timing. Generally, if you advance the cam, it would get you better low-end torque. Retarding the cam will give you better high-end horsepower. But as I said, the comp cams is usually pretty good at their quality control, and there is no adjustable timing set that I know of at this point in time to even make it worthwhile for me even doing it. I'm literally just going to slap this camshaft in it. A real engine builder would check it, but it's not worth my time, and it's not worth checking it on a motor that's really not feasibly worth it. So literally I am putting, and I say that as I'm putting a almost $350 camshaft in this motor, slapping it in. Bunch of people slap it in. As I said, comp cams is good at their quality control. One thing you got to know is that these camshafts, the lobe isn't lifted up. The base lobe is actually smaller than the stock one. So this is where you needing new custom length push rods comes into play, or else this thing will not run right. So new push rods are going to be a must. Again, that would be in a later video, but let me just throw this camshaft in. I already looked down in there. I cannot see any real. This is going to get messy. I'm lubing up my shaft. And get your mind out of the gutter. But I said that on purpose. Oh boy. There was some pressure release there. I did say that on purpose just to be funny. Get your mind out of the gutter though.
We kind of look slightly smaller as each one of these are. Gotta be careful with doing this though. Let me grab a cam bolt so it makes it a little bit easier for me to grab onto this. This is probably really boring to watch. All I'm doing is throwing a camshaft in it. This is where it gets tricky. Gotta be careful. I don't want to damage the bearings. There we go. Alright, it spins good. Alright, that's feels like honey. I feel now. My hands are wrecked.
Alright, now we go to the camshaft plate. So there's 2 bolts right there. They're Torx. I don't know why they're Torx, but one thing you should know about me is any internal bolt, especially when they're like coarse thread, which I think these are coarse, I always use a little bit of red Loctite. Not a lot, just a dab. You don't need a whole lot, just a dab. Very, 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 very little. You don't need to frickin' bathe it. Last thing you want to do. Let's see, this is the... Put this on like this. Start bolts. You also must know that I don't exactly do everything by the book how you should do it in a perfect world. I do everything by reality and basically where I can get away with shit and where I have to do it the correct way. Okay. I believe these bolts are supposed to be torqued to like 108 inch-pounds, which is about like 10 foot-pounds, which that's about right there. Yeah, that should be good. It's not a whole lot, but it's also got red Loctite on it. Alright, so this is the old tensioner. The plunger's in here. We're going to install the timing kit. That's the part number from MELLING for the timing kit that I'm using. Got some torque specs I wrote them down. This one goes here. Tensioner, chain, sprockets, the whole shebang. So this is what we'll do here. We got these bolts again. This is about like this. We'll get some very little dab of Loctite. Each bolt. You can see that very little. Don't drop it. Some of the threads there. This is also about 108 inch-pounds, so about 10 foot-pounds.
And this is a 1/4 inch ratchet, so I'm not reefing on this thing. Okay. Now, clean that off. Where's my gasket?
Alright. So on this is your tensioner. Right here is what you call the grenade pin. This is spring loaded. Without oil pressure, it's spring loaded. Let me grab, I need a ratchet. Alright, I got a ratchet, got my bolts. Alright. As I said, this tensioner is spring loaded. There's a grenade pin on it. That's what they kind of call it. Put some Loctite on them bolts. There's a gasket here. You have to realize on this motor and the single overhead cam motor, they have tensioners that run the timing chain to keep the slack out of it. Without oil pressure, it's a spring, but generally it's always been oil pressure when it's running. Spring's only there for when you start up. And with the pin in it, we're not tightening these down quite yet. Careful of my gasket, like that. Like that. Make sure the gasket's good. I'm going to leave that like that. Okay, so now we have
the timing gear, the timing sprockets. Okay, there we go. Goes on this way. Alright, so this is the front. Alright, so
if I remember correctly, look at the lobes here for number 1. It's always dot dot towards each other. It's always been, I believe, the dot dot towards each other. The camshaft, we're on base circle. For number 1, this is number 1. I'm looking down in the lifter holes to see if the lobes are on base circle. They're on the other side. On the other side, yes, we're on base circle. Okay. So now this is where
this out.
what I really have to do is I have to pull this sprocket back off because I have to put them on at the same time. Come on, there we go. Alright, so we gotta put these on at the same time. The dot dot with each other. If you can kind of see that, you can kind of see dot dot lined up, dot dot lined up. So kind of like this into on the tensioner. I'm gonna have to get a that's a little bit this way, that one's a little bit that way. It might clear up with the slack, so I got slack here, tensioner's not tight. I will have to, alright, this cam bolt is just loose in here. We'll torque that in a moment, but I move the crank around. This is the slack side, if you can see. And basically I take a long screwdriver. If you can see there, the dot lines up with the keyway. This dot point should be in between these two teeth with the dot point. I put something definitely straight, which would be this screwdriver, which I have. Dot point lines up. Dot point gets covered in between two teeth. And then you have it basically go over the center of the bolt, which tells me the screwdriver is straight. This is timed. Alright, so I'm going to torque these roughly about 10 foot-pounds. Got 0. Okay, those are both torqued. But these ones are in plastic. It's about 84 inch-pounds to I think 108 inch-pounds, which 108 inch-pounds is almost I think 9 or 10 foot-pounds. This one up against metal, we'll leave it at that. This one, yeah, this is too little of torque to even register with this one. But pretty sure that's within spec. It's not, again, I don't do everything exactly correct, but I know where they should be. So this is through an aluminum housing. 10 is a little over, but it's fine. A little bit Loctite. This is fine. This, however, you're going through plastic here, so you really don't torque this that much because it's through plastic. It's only inch-pounds. There's Loctite on the back side, so I don't have any problem with this. So now that lined up, so again, if you just check lined up, lined up, lined up. Alright, we're pulling the pin. Pin's pulled, tension's gone, or slack is gone. The timing is still perfect. We're good. Probably keep this. Now comes the part of torquing the cam sprocket bolt, which is 44 to 50 foot-pounds. .48. I have some bolts in the back of the crank with a pry bar. There. Okay. Alright. Sprocket's torqued. There. Check, check, check. Dot covered, in between covered, lined up with center bolt hole. We're still timed. No slack. Good tension. Torque, 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 torque. We're good. I did Loctite these and this because it's internal, and the the hell is it? The bracket. Alright, sorry about that probably hard cut, but the camera kind of died there, but everything's installed, everything's torqued. The thrust plate bolts, 84 to 108 inch-pounds, which is, I believe, about roughly 7 to 10 foot-pounds. Same with these, 84 to 108 inch-pounds, and same with these. They're Again, it's like roughly 7 to 10 foot-pounds. They're all torqued. These are torqued to like 9 foot-pounds. These are torqued to 10 foot-pounds. These are torqued to 10 foot-pounds. I'm very wary about torquing these, but I did torque them to about 9 foot-pounds because it is torqued through plastic. But the thing with these bolts, there is a shelf that I believe it torques to the side of the block because it's just holding the plastic guide. So this one I was extra careful with, but I did torque it, and it is torqued. There's Loctite on these, there's Loctite on these, there's Loctite on these, and there's Loctite on this. Just a wee bit dab, just a little drop on each one of them. You don't need a lot, it's just enough to make sure the bolts do not come loose inside the motor. You can check the torque on these with a very, very 1/4 inch drive torque through the holes here. That's what I did. I checked them. They're torqued. You can move the cam crank. It's timed. You're not going to mess it up. It's timed. Every time you move it back, you'll see dot lined up to dot with the screwdriver. It's timed. So it's stock timed. It's all okay. Everything's torqued. I think I'm going to probably end it here. I'll have to put the front cover on, probably the front dampener, and that might be in another video. I also have to do the oil pump. The cam synchronizer will be its own video. And the oil pan, the whole bottom end might be another one. But for right now, torqued, all okay. It's timed. I can move on now. This is all finalized. So that's the camshaft install. I'm not degreeing the camshaft, nothing like that. I don't have the tools for that, and it's not even worth it because comp cams quality control is usually pretty good, and on top of it I don't have an adjustable timing set, so it's not worth it to me to even bother. I will throw this thing together the way it is. If it has a running issue, then I'll cross that bridge when I come to it, but for right now it's in there, torqued. Number one's on base circle for the cam, so everything is good. I think that's going to be it for this one. So subscribe to follow my hot garbage, or not if you don't want to, but well, I'll see what I'll do for the next video. I'm just slowly getting this engine back together to consolidate my parts. See ya.